Right, so for those of you who are doing extended science, we also want to look at the topic effects of forces in more detail. Now, objective number 1, you guys are expected to be able to describe how forces may change the size, shape, and motion of an object. So, forces can change the size, shape, and motion of an object. Now, let's take a look at each and every one of them, one by one, each and every one of those points. Now, taking a look at size and shape, suppose I take a loaf of bread and I crush it. So its size is going to be smaller and its shape is going to change. I might crush it into a ball. So it goes from a sort of like rectangular prism shape to a sort of like spherical shape. Okay? So the reason why I'm able to crush that loaf of bread is because I'm applying a force on that loaf of bread. Now let's take a look at a car which is moving on the road at constant speed. Now, if you step on the gas pedal, the car will accelerate because the force due to the engine is increased. Right. So there's a force there, a resultant force, which is now causing a change in the motion of that vehicle. It's causing the vehicle to accelerate. So basically, you guys should be able to identify the presence of a force by looking for changes in size, shape, and motion of bodies. Right. Now, let's go on to objective number 2. Now, objective number 2 wants us to be able to plot and interpret extension load graphs and describe the associated experimental procedure. So, if we want to plot an extension load graph, basically what we need to do is to follow these steps which I've written down there. So, we need to set up an apparatus as shown there, whereby we have a hanging spring. And then we need to measure the initial length of the spring, which in this case happens to be 8 centimeters. Okay, that's the initial length. After doing that, we're going to add 100 gram mass, and then we're going to note the extension. So the extension is actually calculated by subtracting the initial length from the new length. Okay, that's how we calculate extension. So we're going to repeat this about 6 times, consecutively adding 100 gram masses each time. Right, so we'll come up with extensions for each stage whereby we add 100 gram mass. We'll come up with an extension, and then we'll compare that to the stretching force, and then we'll come up with the extension load graph. Right, so at some point, which is called the elastic limit, okay, we'll no longer have direct proportionality between the force and the extension. So what is direct proportionality? Direct proportionality simply means that if 100 grams causes an extension of, let's say, 3 centimeters, okay? If it causes an extension of 3 centimeters, then 200 grams should cause an extension of 6 centimeters, okay? Right. So basically, that is direct proportionality. And direct proportionality exists before the elastic limit, okay? Right. So basically, that's the way in which we can determine an extension load graph experimentally, okay? Right. Now, you guys also expected to state Hooke's law. Now, if you take a look at Hooke's law, now you should know that springs extend in proportion to load as long as they are under the limit of proportionality, okay? As long as they are under the limit of proportionality. So basically, what Hooke's law is stating is that extension is directly proportional to load as long as we are under the limit of proportionality. Okay, right. Now there's a formula which is there. Load in newtons is equal to spring constant in newtons per millimeter times extension in millimeters. Okay, right. Now let's suppose the extension is in meters, which is unlikely. Then the spring constant will be newtons per meters and the extension will be in meters. But such extensions are, beyond the scope of my imagination. Most extensions will be in millimeters. Okay, right. So the spring constant will also be in millimeters. So the load is F. It's a force. It's measured in newtons. The spring constant is K. Okay, and the extension is X. Right. You need to remember this. Right. Now, the next thing we want to look at is objective number 4. You guys are expected to recognize the significance of the term limit of proportionality. Okay, limit of proportionality for an extension load graph. Okay, so the limit of proportionality, right, is the point above which the load and extension, okay, the load and extension, these two guys here, right, would no longer be directly proportional. So basically, in other words, the limit of proportionality is the point above which Hooke's law will not apply, because Hooke's law states that extension and load are directly proportional. If you put a load of 100 grams and you get an extension of X, if you put a load of 200 grams, you should get an extension which is 2 times that of X. So there's proportionality there, right? So when the limit of proportionality point is surpassed, right, the load and extension will no longer be directly proportional and Hooke's law will no longer apply. So basically, Hooke's law is only valid for straight line parts of the graph. It's only valid for straight line parts of the graph. That is up to the limit of proportionality. Beyond the limit of proportionality, Hooke's law does not apply. Beyond the limit of proportionality, the force and extension are no longer directly proportional. Okay, they are no longer increasing by a magnitude which can be connected mathematically. Okay, right. So basically, let's take a look at this to understand what I am talking about. So if you look at this point here, this part is straight. So the force and the extension are directly proportional to each other. Okay, the force and the extension are directly proportional to each other. But when the limit of proportionality, this point, when that point is reached, the force is no longer directly proportional to the extension. Hooke's law is no longer observed. Don't worry about the elastic limit. It's not there in your syllabus, so we're not going to talk much about it. Okay, right. Now, the next thing that we're going to look at is how friction impedes motion. But I've already highlighted this in the Combined Science Core video, and I'm going to send you guys a combined video of that part and the extended part. Okay, now this brings us to the end of our lesson. Have a good day.